think 5 of them, because we've come out 1, 2, 3, 4, 5 places. So someone on their calculator do 581 divided by 99,999. And I bet you do not get 0.00581581581. Those zeros have a major impact on things. Let me see. Let me see.
Your eyesight can't see stuff?
Well, no, but you need to turn that into a decimal. I'm saying take 581 over 99999, divide it, and what's the decimal you get? What do you get? Did you do it? No. Look, it doesn't work. I know it doesn't work, but I was just trying to get someone to verify that it doesn't work. Okay? So if the pattern starts right away, right, with no zeros in here, then your answer is just that number over that many nines. But if the pattern starts further down the line, then you have trouble.
This thing reminds me of when you did 0.99.
Did anyone try it? Didn't work? Didn't work. All right, that's a take-home bonus due next class. So what I want you to do is exactly what we just did. Break it all apart, try and find a pattern, create your sigma notation, try and get it to n-1. It's not going to be fun. I mean, well, it is fun, but it all depends on your definition of fun. Okay, oh my gosh, it's already 4:24, my God. Harmonic series. Harmonic's fast. I don't know. That's about right. We'll be okay. 15 minutes, we've got time. I'm going to pass around the sign-in sheet. Harmonic series. So here's what a harmonic series looks like. It's a constant divided by a linear expression in n. Here's what I mean. Sum n equals 1 to infinity of 1 over n. That's the one we started class with, isn't it? Is that a constant over a linear expression in n? The variable's n here. That's a linear expression. N is being raised to the first power. Anytime you see this, it's harmonic. All harmonic series diverge. Okay? They all diverge. Now, I will try and convince you of that in a minute, but just for now, I'm trying to tell you what they look like. How about this one? Yes, that is harmonic. Linear, a constant over linear expression in n. Doesn't matter that the 2's there. It's still a linear expression.
What's so important if it always diverges?
It always diverges.
So what's so important about that?
Is that if you have it, you know it diverges. Like, there's not a lot of work you have to do. You have to identify it. Yep. So on a test, if I give you a series like this and ask you, does it converge or diverge, you'll just put harmonic series diverges. Done.
How do we prove it's harmonic?
You don't have to prove it's harmonic. You just have to identify it. Now, if you sit there and, let's say I change this to an n squared, and you tell me harmonic diverges, I count it wrong. Right? Because it's not harmonic. Or if you try, like if you do this and you say you think that that's geometric, well, it's not geometric. The n is not up in the exponent, the n is down in the base, so that's not geometric. So these harmonic are quick. As long as you can identify it, you're done. Why is it diverge? I want to show that to you. Okay, so harmonic series always diverge. I'm going to try and show you. This is not a formal proof, okay? This is not a formal proof, but I think I can get you to maybe be convinced. And this is the standard way of doing it. I'm going to do the most basic harmonic series there is, which is 1 over n. We know that this is 1 plus a half plus a third plus a fourth. I'm going to write all the way out to the 16th one. Plus a sixth, plus a seventh, plus an eighth, plus a ninth, plus a 10th, plus an 11th. When we looked at this one, I asked for like an opinion. Do y'all think it flattens out? Or do y'all think it gets bigger? And we kind of had disagreement within the class, right? That blue one, that blue sequence on the right-hand side, what I'm saying is that it will diverge. It's going to become infinite. And here's how we can prove it. I'm going to prove to you that this sum is bigger than infinity. Right? Here's how I prove it. First of all, I want you to skip the first two here. Just start with these two. Let's add these two together. What's 1/3 plus 1/4? 7/12. Okay. Plus, I'm going to take not the next two, not the next three, but the next four. And I'm going to add those together. So who has a fancy calculator that can do this and give you the nice fraction answer? Who can do 1/5 plus 1/6? Is that a fancy calculator? Okay.
I don't know how to use that.
Here, give it to me.
My other one, my regular one broke, so that's why I have a fancy calculator.
I may not know how to use this. Let's see, I'm doing 1/5 plus 1/6 plus 1/7 plus 1/8. 533 over 840. 533 over 840. Plus, now I'm going to take not the next 1, not the next 2, not the next 3, not the next 4, not the next 5, not the 6, 7. I'm going to take the next 8. Okay, so first I took 2, then I took 4, then I took 8. What do you think I'll do on the next step? I'll take 16. On the next step, 32. Okay? And think about it this way. Think about it this way. Here, you may have this. Thank you. I'm not going to add all those up, okay? But what is the smallest number in this list right here? What's the smallest of those numbers? 1/8, right? This is bigger than an eighth. This is bigger than an eighth, and this is bigger than an eighth. What would happen if I took 1/8 4 times? What would I get? 1/8 plus 1/8 plus 1/8 plus 1/8. Wouldn't that give me 4/8? Isn't that a half? What I'm getting at is that these 4 together in black is bigger than a half. Isn't it? This is bigger than a half. These two together are bigger than a half. The next 8 are bigger than a half. Why do I know that? Because the smallest one's 1/16. And if I were to take 8 1/16ths, that would be 1/2. Does that make sense? So here's what I've got. The next one, whatever it is here. And then I take the next 32. And then I take the next 64, then the next 128. Am I ever going to run out of them? No. Each one of these, do you agree, this right here, this whole sum is bigger than 1 plus a half plus, isn't this a half? Bigger than a half? And the next one's 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 bigger than a half? Forever? What's 1/2 plus 1/2 plus 1/2 forever? Infinity. That's infinite, right? It's like adding up a plus a plus a plus a. That's infinite. And this sum has to be bigger than that. So this must be infinite. I hope that convinces you. I don't know if it does.
I think I lost you in the last 10 seconds.
The what?
The last 10 seconds.
What part?
What did you say? So this. You said that.
These two numbers together
Bigger than.
are bigger. That right there is bigger than 1/4 plus 1/4, right? Which is a half. So these two together are bigger than a half. This one right here. This, of course, is this. This one is this, right? These two together are bigger than this. Okay? These 4 together are bigger than 1/2. these 8 together are bigger than a half. Right?
So is 2 to the infinity smaller than 5 to the infinity?
Is 2 to the infinity? What do you mean? Where are you getting
So
that
you're,
from?
You're really just adding infinite halves. But
I'm-
then on top you're adding infinite, a little bit bigger than a half.
Uh-huh.
So they both go to infinity.
Yeah, they both go to infinity. But this one goes faster.
Yeah, it goes faster.
That's all.
So that's
The only way you can be bigger than infinity is if you're infinity.
yeah.
Like infinity is not a number. It's just kind of like you and I are racing, and you're behind me. We're both going to infinity. I'm just in front of you. This one is in front of this one, so to speak. Yeah, it's like a bigger infinity. You can't say equal because infinity is not even a number.
Yeah.
Yeah.
So then how could you even say infinity could be bigger than an infinity?
In this, if you start taking the sum, right? Then, like if we started comparing 1, 1, half, half, this was now ahead of this one. This next one would be ahead.
Yeah. So
Right.
Yeah, it gets infinity.
It's, yeah, I understand what you're not happy with the idea that infinity can be bigger than infinity, but if this sum is bigger than this sum, and this sum approaches infinity, then this sum must approach infinity also. So all harmonics diverge. What? Yeah. We can actually do this a different way. We're gonna remember I said we're gonna have common series, right? 4 of them. And then after that, we're gonna start looking at techniques on trying to like figure out how to get like convergence or divergence of general series. We're gonna have a test that we're gonna run. It's called the integral test. And we'll actually be able to show that that one diverges by the integral test. And you might be a little more convinced once I run that test on it. All right, the last one we have is harmonic or telescopic. Collapsing, we don't have enough time for it, all right? But I will show you one last thing. I had my class earlier, we were talking about this. If you have, let's say, sum n equals 1 to infinity of some sequence a sub n times some other sequence b sub n. The question that we asked was, can you split this up into the product of 2 series? What do you think? And not only that, why would this be useful? What if you know that this by itself converges and this by itself converges? Then you could split it into 2 and see, okay, get this convergence and this convergence, whatever they go to, and multiply the 2 answers. But are you able to do this? So let's just take a quick gut instinct vote. How many of you think yes, you are allowed to? How many of you think no, you cannot? Okay, let's look at the algebra behind this. What does this left side really mean? So start with n equals 1. And what do you have? A1, B1? Plus, right, because it's a sum? Okay, next, A2, B2. Next, A3, B3. Plus, dot, 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 forever. Does that equal this? All right, well, what's this sum? A1 plus A2 plus A3, right? In parentheses, dot, 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 forever, times, so that's this one, which is B1 plus B2 plus B3 forever. See that? Now let's do like a FOIL. It's not FOIL, it's not 4 terms, but I would do this times this, this times this, this times this. I would have to do it infinitely many times, which I couldn't, but let's just see the pattern. This would be A1 times B1, which is A1, B1. Hey, I've got an A1, B1 over there. Looking good. Plus A1 times B2. A1, B2. And that is not over there. Which means there's things in this sum that don't appear in that sum, right? You're never going to get 2 different numbers on the bottom over here. But over here you are. So these two sums are not equal. That means you're never allowed to take a series that has products inside and split them into individual series. You can't do it. Now that, see, I still have time. The reason why that came up earlier is because I just showed my class a collapsing, a telescopic. We didn't get to talk about it, but this was the one I gave them. Right there. Okay, is that geometric? No, n's not up in an exponent. Is it harmonic? Is the numerator a constant? Is the denominator linear in n? No, it's quadratic. So my class earlier said, hey, well, couldn't we do this? Each of those are harmonic, right? Diverge, diverge. Then it should multiply to diverge. And I said, no, you can't do that. And they said, why? So I explained just the way I explained to you why you can't do that. Understand? So we're stuck with this. And the question is, how do we do it? So we'll come back and do that Tuesday. I know for sure everything we've done up, I didn't give you homework. I know you want to practice when you get home. Everything I've done up to this point, everything I assigned for homework today will be on the test. What I do on Tuesday may not be on the test. All right, this is page 443. We have 7 through 11. I have to skip around here because there's some things we haven't done. 13, 16, 17, 20, 23, 24, and then 31 through 34. 31 through 34 are those ones where you have decimals that repeat. And then these are all just like either geometric or harmonic. Have a great weekend, everyone. I'm kind of in a hurry to get out of here. If anyone needs to talk to me, make it quick because I got to go.
One question I had, what about this? Is this true?
Again, I mean, what does 5 to the infinity mean? So you can't even really say 5 to the infinity.
Infinity.
Yes, but this one does go, here's what you would need to write instead of that. Limit n goes to infinity of 5 to the n greater than limit
So that's
n goes
true.
to infinity of 2 to the n. Well,
But that's kind of the same idea. It raises the same question.
here's a more profound question. Limit n goes to infinity of 5 to the n over 2 to the n. What would that be? Versus limit as n goes to infinity of 2 to the n over 5 to the n. So look, this might give you a better insight as to what's happening here. This goes to infinity over infinity. Right? Infinity, infinity. But this one's going faster. If we convert this to a geometric,
Bigger than 1.
yeah, this is bigger than 1, right? This 5 over 2 is bigger than 1. This thing's going to go to infinity, which means that the numerator is dominating the denominator. Here, it's like 2/5
Yeah.
to the n, which is smaller than 1. This one goes to 0. So even though they both go to infinity, this one goes so much faster than this one goes that it smashes the ratio down to nothing. So,
makes sense.
yeah, that better? Good. Okay, yes,
Are you doing Cal 3?
in the fall.
For in online or face-to-face?
Both.
Okay.
Yep, I need to double check. I have other students asking me, but I believe I've been told that there's only one fall Cal 3 face-to-face.